Hi, I'm Matt. Today I'm going to give a brief overview of the modern data stack and how you can build a data system using open source software. Okay, so here's the system diagram I used for this e-commerce project. It starts off with a bunch of different data sources. This is a Shopify app, so we pull in data from the Shopify API. We use PostHog for web analytics, meta ads, and even some Postgres data. And we used Airbyte via Cloud Run job to ingest this into our data lake. Now, in this case, our data lake is where we store the raw data, and we use Google BigQuery. Next, we use dbt to transform this data into a usable format for our analytics tool. So dbt does things such as creating new fields, renaming fields, removing fields we don't need. And this dbt job was hosted on Cloud Run. Our data warehouse, the transformed data, was also stored in BigQuery, which allows for quick access for these analytical queries. And then I use Lightdash as the front end, which includes the dbt semantic layer, and then where the users can go to actually view the analytics. In this case, we used Airbyte as the extract load tool. There are a variety of different options, including Fivetran, Stitch, but Airbyte is a powerful open source tool that has a bunch of hundreds of pre-built connectors, so we were able to use it for all of our data sources. And some of the benefits are it can easily transform your data into a relational format. One of the features of the modern data stack is flipping around extract, transform, and load, and running it as extract, load, then transform. Now, the benefits of this are that data storage is cheap, so we can load essentially the raw data into our databases, and then we can run transformations on it there. And this way, whenever we need to make changes, we don't need to re-ingest the data. We just update our dbt models, and those transformations can instantly take effect. Okay, so now we've loaded all of our data via Airbyte into our data lake in BigQuery. Now we want to transform this data into a usable form using dbt. And storing it in a new schema within BigQuery. So what is dbt? It's really just a simple way to write, organize, and validate SQL-based transformations. Here's what a dbt project looks like. You have these models. So for each of our transformations or tables, we create a SQL file. Here we'll look at the orders.sql. So these are orders from Shopify. And so it takes this raw data and it will transform it into a usable format. So, up here you can see an example of a macro. This is just to verify that we never pull in duplicate orders. All this does is, partition over the ID field and only select where row number equals 1. Fields that we want to add, like here, the device type a user has. Here we're determining if customer that ordered was repeat or returning. A bunch of different data transformations here. In orders, this is fairly complex. But that gives us our finalized tables. Now we've completed up to the dbt step, and we have our transformed data in our data warehouse. So all of these steps up to this point, the front end, it is agnostic of the front-end tool. Now, for our front-end tool, we chose Lightdash. Lightdash is an open source BI tool designed for data engineers. It uses YAML files as the semantic layer. So in this, users can define metrics, dimensions, data relationships, formatting, and a variety of other things. Now, this semantic layer, these YAML files, aren't necessarily transferable across different BI tools. Looker has Looker MS, have different ways of defining schema for consumption on the front end. But once you have defined one of these YAML files, it can be useful, or it will make it a lot simpler if you do want to change BI tools to switch to a new one, versus if you don't have the semantic layer, then a lot of the logic is specified internally in the tool, and it can make it extremely difficult to migrate to a new front-end tool. So the semantic layer acts as a translation layer between the technical data structure and the business concepts. And as we mentioned, dimensions, metrics, formatting, relationships. But let's take a look at what this actually means. All right, so here's the order's semantic file, the .yaml file. So for Lightdash, kept it simple. We put the SQL files right next to the .yaml files. They're named the same as the table. So here we have our first, in this case, I'm defining all of our columns. So we're looking at the orders table. It's just a description of what this data is, and then all of the dimension columns here. So you can see in this case, we specify the order ID, and I said I wanted it to format as a number without commas because the default format was for it to have a bunch of commas, which wasn't right for an ID. But you can specify any kind of format here, for currency, rounding, etc. So we specify I like to specify all of my dimensions first. In the orders table, there's quite a few of them. But if we get down here to the meta section, here we can specify, here I specify a SQL filter, and this is so shops can only see their own data. We can group the fields within the GUI front end. We specify data relationships. So orders has a lot of data relationships. A simple one, we want to know which customer information on that order, where the order took place, where the customer came from. And so we specify the joins or data relationships here, and then we specify the metrics. So I want to know net profit. We can add some computation here, format, which type. But here we define all the metrics that the user could be interested in. So then going into Lightdash itself, then you can see how we have the orders table. We have all of the dimensions we specified. And then we have all the metrics we specified. And then we have all the data relationships specified within a schema file. So yeah, that's it for the modern data stack. That's a fairly basic example. There are many other things such as testing and validation that could be added for a more robust system. But I think that will get you started and give you a good understanding of how the pieces fit together and how you could potentially use them within your project.